Hello everyone, I welcome you to this 30 days Masterclass series on electric vehicle design. I welcome you everyone here. Yes, I welcome all the participants. Am I audible? Can you please confirm? Am I audible? Yes, I welcome Sankita Devi, Akash, Chandra Prakash, Vikash, Malati. Warm welcome participants. Warm welcome. Lokesh. Yes. Dr. B.M. Nayak, Sarvesh, Vishal Yadav, Makesh. Warm welcome participants. Am I audible? Can you please confirm? Yes, thank you participants. Thanks for your valuable reply. Yeah, thank you. So this is the 30 days masterclass series. So today we are going to discuss about the EV design. There are few stages are there. Yeah, we will discuss one by one. I would like to invite to everyone here. Suppose if you feel my voice is disturbance. So please bear this today. Today I'm in remote area. So please bear this delay. Yes. Very good evening. Yes, I once again I welcome you. Yeah. So this is Malayappan. Yeah, this is Malayappan from Pantech eLearning. So I have completed my Master of Engineering in Power Electronics and Drives. So from Gindi Engineering College in 2004, and I have a vast experience in the field of like power electronics and motor control, advanced power electronics, EV design, power supply design. So these are all my research area. You can ask me anything about these areas. And about Pantech, Pantech is a educational equipments manufacturing company. So we manufacture and provide the sales and service to the to the engineering colleges to fulfill these laboratories. Like for the Department of EEE, Computer Science, Electronics and Communication Engineering, we will provide you complete turnkey based solutions. And our vision is to help 10 million students to learn the technology in easy way. So far actually we are running this 30 days masterclass series from COVID, like 2020. We have successfully completed about 60 30 days programs on various domains. So our vision is to facilitate provide the platform to learn the technology in easy way. So who are all, suppose if you can be a engineering student, or you can be a polytechnic students or school students or whatever it is. Our main aim is to provide the simplified platform. So if you attend your if you attend this 30 days series, definitely I ensure that you can develop your own EV design with in the Matlab Simulink tool. So I will tell you what is in detail. I will give you the complete insights about the technology and all everything. So what the industry people are using, what you have to concentrate to enrich your skill set. So everything I will share you one by one. So try to engage with the entire 30 days series, right? Then announcement, you will get attendance form in the live chat. You will get attendance form in the live chat. Yeah, you are not audible. Okay, voice is very low. Just a second. Let me check. Now is it okay? Now is it okay? Dear participants, now is it okay? Yeah, Mr. Akash. Yeah. Yes. Now I think I have corrected my volume. I have increased my volume. I think so. Can you hear me? Can you hear me? Now is it okay? Yeah. Thank you so much. Thank you so much. Yes. So you will get a attendance link in the live chat at 7:45 p.m. So please do submit your attendance on daily basis. Right? Use the same email ID for next 25 days. then only your attendance will get marked. Otherwise, your attendance will not marked. Suppose if your attendance is not up to the 25 days, then you are not eligible to get a certificate, right? So I hope you understood. Uh, right? Right. So before starting the session, I would like to hear your department. Can you type your department's name in the comment box? Can you just type your department name in the comment box so that I can verify? Dear participants, can you able to hear me now? பவர்ல என்ன பண்றது? சார்ஜ் இருக்கு, வைஃபை ஆஃப் வரல. சாட்டர்டே 5 minutes செஷன் heavy fluctuation. Still இது இருக்கு, ஆனா ஸ்ட்ரீம் ஆகல. டைப் பண்ணிட்டேன் இல்ல. இல்ல இல்ல ஹாட்ஸ்பாட் நெட் இல்ல. Hello, am I audible? Can you please confirm? Dear participants, am I audible now? Now is it audible? Hello, am I audible? Can you please? Hello, yes, can you confirm? Am I audible now? Yeah, sorry for this inconvenience. Here, internet fluctuations, heavily internet fluctuations happened. Hello. Yeah, I think now it is audible, right? Dear participants, can you please comment? Dear participants, can you please comment? Confirm? Yeah, right. So I will continue. I will continue the session. In this 30 days EV design masterclass series, so we are going to discuss in detail about what is EV, what is the simulation software which we are using, which we are going to use in this session, as well as what the industry people are using. and similarly what is the power electronics, and in detail about the power electronics. So everything we will discuss in detail, right? So I request you everyone, so try to engage with the entire 30-day class. Then only you are then only you can increase your your idea in this domain, particular domain. If you put your just 30 minutes on daily basis for to learn these concepts, I ensure that you will become a master. And so I have separated these models up to five models: model 1, model 2, model 3, model 4, and model 5. So in the model 1, we will discuss about what is a simulation software, why it is required, and how to start our EV research, where to start. So everything we will discuss in the model 1. And model 2, whatever we learned in the model 1, so the topic will be utilized and in the model 2, and verify the results, right? Similarly, the motor model 3 also is a complete motor model, so motor control models. So we will discuss about the five motors. So each and every motor will have its own it has its own controlling methods. So with the model 2 we can control the motors, and finally we can integrate the motor control and battery module in the EV design, EV structures. So this is the detailed detailed models. So we will discuss one by one, right? So before get into the electric vehicle, so as we know that we are using the conventional vehicles, the conventional vehicles nothing but, so we are using about conventional fuels. So there also some batteries are used, but that battery is only for the ignition of the diesel, conventional engines, just for starting purpose only. So it no longer going to utilize in the to the engine operations, right? And similarly, so due to the technology advancement, so the electric concepts has been integrated with the conventional vehicles. So initially they have used the electrical power to start the vehicle and to stop the vehicle, and some assistance while the vehicle is in uphill or downhill, something like that. Whereas nowadays the entire system will have a two parallel power. One is the mechanical power and another one is the electrical power. So for example, if you fill like a conventional fuel, and similarly that entire system will have a parallel electrical system. So suppose if the vehicle covers 10 kilometers with the conventional fuel, parallelly the 10 kilometer will be provided by the electrical system, right? So that kind of technology also available with the hybrid electric vehicle. But full electric vehicle, if you compare with the conventional, the hybrid electric vehicle will have a more advantages. Whereas the conventional fuel is the supply is very limited. Whereas the electric vehicle, if you take electric vehicle, that is the numerous sources are available to produce the electric vehicle. So in that aspect, still it has its own limitations. If you take a cost effective, that is called a maintenance cost, and then controlling mechanism compared to the IC engines, then this is very simplest mechanisms. And similarly, it's the EV systems are highly environmental friendly systems, and you can utilize it very easily, and you can take a power from the renewable energy systems also. Whereas where is the limitations? So again, if you take the infrastructure development, so the limited charging stations are highly limited, right? The range of distance. For example, if you take a conventional fuel, wherever you go, you can just fill. You can refill your vehicle. It's a matter of seconds. Whereas in the EV system, so it's not like that. So you have to wait. You have to bear your time. Similarly, the temperature variations. When your vehicle speed is very low, the motor current will be very less. If you are driving your vehicle with a full load and maximum acceleration, the current will be very high. So the current is directly proportional to the temperature. So obviously, the temperature handling is the biggest challenge in the EV system. And one more limitation is there. See here, whatever we are calling the EV, but battery is ultimately is going to be a king for this vehicle. So again, how we are going to handle the batteries? So not a, I mean not a unused batteries. This is used batteries. So again, this is the biggest challenge for each and every country. Not only countries, the entire world, it's going to face that problem. Right. So in that aspect, there are some, I mean, limitations are there. So that we can be overcome with the help of latest technology. Nowadays, single charge with 100,000 kilometer and 1,500 kilometer vehicle, 1,000 kilometer also you can cover with the EV vehicle. So that kind of technology also available right now. So, but not in up to the market, but still it is in the research level, right? So now how to start, where to start the EV design? So first you should understand the theoretical concepts, and then you have to go verify the theoretical concepts with the simulation, and finally you have to verify the hardware. So once if the hardware is validated, then only you can go for the production. So now, since you all are comes under the various domain, so here we are going to understand what is the stages of the EV productions. So initially they will develop a theoretical concepts. The theoretical concepts nothing but the specification level. So whether it is a two-wheeler or three-wheeler or a, 1,000 kg vehicle or 2,000 kg vehicle or what, I mean, level of a vehicle and a range of the distance coverage and temperature specifications and the vehicle dimensions, everything. So here we will discuss all the concepts. So once the theoretical concept has been finalized, then we will move into the simulation level. So the simulation level nothing but like there are variety of softwares are available to verify the formulas whatever we developed in the theoretical level, right? So in that we used Matlab Simulink. So that is a widely used softwares to validate all the concepts like electrical concepts and algorithm concepts and physical concepts. The physical concepts nothing but that mechanical parameters, all the real-time mechanical parameters has been taken into the consideration. So that is called system level simulations. If you if you solve your problem with MATLAB Simulink, so that will generate one results, right? So that result will be equal to the real time data, right? That's why we are calling system level simulation. And you once your concept has been verified with the simulation, then you can go for the hardware validation. Again, if you got a output, same output from the simulation as per the simulation results, then you can go for the production. Then only your vehicle will be successfully will it will run in the on the road, right? So that's why we are calling it is a system level simulation. So to implement the entire simulations, we are going to take a MATLAB, right? So with the MATLAB we can implement motor control concepts, battery management system concepts, vehicle dynamics concepts, and then control algorithm concepts. So everything we can verify in this simulation, in this MATLAB itself. So I hope you heard the name of the MATLAB Simulink. Can you tell me anyone is new to the MATLAB? Anybody is new to the MATLAB? Anybody is new to the MATLAB? Can you please comment? Anybody is new to the MATLAB? Okay. No. Okay, new to the MATLAB. If you are new to the MATLAB, please comment the comment box. New, I am new to the MATLAB. Please comment in the comment box. I am new to the MATLAB. Okay, I heard about MATLAB. Okay, great. Yes, Poonam. Okay, okay. So many of you don't know about the MATLAB. So I will tell you what is MATLAB and where we can get the MATLAB, how we can install the MATLAB. Everything I will tell you. So try to engage the entire sessions. Try to engage the entire session. So this is called MATLAB software. So with the MATLAB software, we can I mean what we can do all the kind of electrical as well as the mechanical concepts. We can implement the mechanical concepts. So here the biggest advantages in the mechanical MATLAB, you no need to write any C level C programming. I mean it's a kind of code. So here everything is available as a block sets. So everything is available as a block sets, right? So here, so with the help of block sets, simply you just to take a block and then you can connect together. Then you can easily solve the particular equations. For example, if you take C is equal to A plus B, so straight away you can take a block for C and you can block for A and B. And if you interconnect each together, then you will get an answer for the particular solution. So like that, the MATLAB will provide the complete solutions, right? With this MATLAB is a computer software, so that you can easily download from the Google, and so they will provide you the trial version. So you just download after this session. I will send you the link to download. You just download the softwares, and you can install into your computer or your laptop, so that you can follow the experiments. See, actually hereafter we are going to work with the Matlab Simulink, right? So you can follow my experiments, so that you will acquire the concepts, right? So if you know the MATLAB, you can implement the complete powertrain architecture. You can implement the powertrain architecture. You can implement the vehicle. You can analyze the vehicle performance for various conditions. You can implement the ADAS algorithms, so that nowadays all the vehicles that comes up with ADAS concepts. So you can implement your own algorithms, and the same algorithm again you can download into the hardware. So that kind of hardware also it's available. So the software will support for that, right? So I will tell you, this is the one case study. Before that, I will tell you where you can download the MATLAB. So just to go to Google, just go to Google, just go to Google. Yes, so just to go to Google, search MATLAB Simulink or MATLAB. Yeah, MATLAB download. Just search Matlab downloads. The MathWork will provide you the link, right? So the MathWork will provide you the link. So you just enter your email, sign in your email ID, and you can download the 30 days trial version. Then you can install. Suppose if you still if you are having doubt to install the MATLAB, so just to go to YouTube, just go to YouTube and search here MATLAB installation. MATLAB installation. So if you search, you will many videos. So in MATLAB itself, they have given the videos. So you can use it for your based on your system computer specifications. You can use it whatever you want, right? I hope you understood the link. So actually now I cannot share the link. I once if the class over, then I will share you the link, right? Is it clear? If you're clear, so please comment in the comment box. If it is clear, so please comment in the comment box. Super clear. I'm just waiting for your reply. Attendance link will be shared shortly in the chat, so please wait. The software is free. Yes, the trial version, the people will be provided as a trial version. So see here, this is the temperature system which is available in the electric vehicle. So there are the two systems. So one is that AC system, and another one is that cooling system. So in the vehicle there is a battery as well as the cooling system, right? So now we have to develop an integrated system. So with that that system should maintain the battery temperature as well as that cabin temperature, right? So the battery is the motor, vehicle is loaded high fully, and if it is reached the maximum level of the speed, then the motor will draw a maximum momentum. As we know that the current is directly temperature, so we have to mount a temperature sensors. So there are the three different sensors. One is that battery out ambient temperature, and battery inlet temperature, I mean current in and out temperature, and battery body temperature. The three sensors we have to mount on the battery, and we have to monitor. So here, to monitor to develop an algorithm for this one. So this is the physical model of the previous system. This is the block diagram of the cooling system, and this is the physical model of the system. See here, this is the battery model. So here we have to measure the battery cell temperature, and battery ambient temperature, and current current carrying conductor conductor temperature. The three temperature has been monitored, and the equation has, the KVL equation has been developed, and the same can be implemented in the Simulink, right? So based on the current value, so here we have to actuate the refrigeration system. So if you turn on the refrigerator when the temperature is high, we can apply the refrigeration system to pull down the temperature. Similarly, if the battery temperature is very low, so we can apply a preheater, that is called positive coefficient heater. So this heater will generate a heat to reach the standard level, right? So this is the integrated system. Suppose if the physical model, each and every model can be implemented in the Simulink model. So we can take a what a resistance, and then ambient capacitance between the two layers. And similarly, when the current is flow, that there will be the fringing effect. Due to the fringing effect, the inductive parameter also will be it will exist during the operation. So that conditions also will be taken care. So for each and everything, if you solve the applications, then you will get a two kind of results. One is the dotted line is the simulation result. The dotted line is the test results, and the bold lines are the simulation results. See here, the both the results are almost equal. That is the 99% is equal. So that's why we took Matlab is the best software to simulate the entire EV system. See, this case study has been verified by Mahindra Research Group, which is located in Chennai. So they have released this result. So based on this only, I have selected. I have actually personally I suggest you everyone, if you are being an engineering student, you definitely, if you know the MATLAB, then you will get a job in the EV industry. So that's why I suggest you personally, right? So my objective, after this 30 days, you will develop this similar kind of EV entire system, and you can verify the output. Are you ready to learn these concepts? If you are ready to learn the concepts, please comment in the comment box. I am ready. If you are ready to learn the concepts, please comment in the comment box. I am ready. Yes. Thank you. Thank you, participants. Yes, I am ready. Thank you. So now, see, as I told you earlier, so first what we have to do, we have to do the dynamic analysis. That is called the theoretical concept. So first we have to collect the specifications of the vehicle. So how we can develop the specifications, the theoretical concepts. See here, yes, I will tell you. Uh, So first we should know the vehicle basics. So what are the vehicle basic concepts? See here, if you are going to if you are going to park your vehicle on the flat surface, so there will be some different forces will be applied. So now, if at the standstill position the vehicle will not get moved, how the vehicle can be moved? how the vehicle will get moved from its standstill position. See here, this is called the push force and this is called the friction force. So the push force nothing but this force has been developed, this force can be generated with the help of motor. Okay, so that force should be higher than the friction force. Then the vehicle will get forward direction. Suppose if the friction force is high and then push force is less, then what will happen? The vehicle will be in the reverse direction when the road is in the inclined position, right? The vehicle will be in the reverse position. So now we have to identify what are all the friction force. What are all the friction force? So now let us take one by one. So the friction force nothing but the gravitational force due to body weight and aerodynamic drag force. So now if the vehicle moves into the forward direction, so due to the what air density, so the aerodynamic drag force will be generated. So that can be calculated with the help of vehicle specifications. So if you go in detail, so all the opposite forces, you can call it as a tractive forces. All the opposite forces to the vehicle direction. So that force you can call it as a tractive force, total tractive force. So now you have to identify what is the total tractive force and the vehicle velocities. The vehicle velocity nothing but, suppose if you are assuming that my vehicle should run at a 40 kilometer per hour or 100 kilometer per hour, otherwise 200 kilometer per hour. So that specification, right? If you are going to buy any new vehicle, so the people will tell you my vehicle will reach for 100 kilometer per hour at steady state conditions, and initially it will reach 100 kilometer per hour within a fraction of seconds or 5 seconds or 10 seconds. The people will tell you, right? That is called a specification. So that speed is called the velocity of the vehicle, and that kilometer per hour, right? So you can choose your own specifications. I will tell you how to select all the details, all the parameters, right? So now let us calculate one by one total tractive forces and then velocity of the vehicle. So this is called the total tractive forces. So the total tractive forces can be classified into four types. One is called the rolling resistance force, aerodynamic drag force, hill climbing force, and then acceleration force. Right? So the rolling resistance force nothing but each and every force we can calculate accurately and we can apply the values to achieve the motor power, right? So once if you got the motor power, then we can verify with the we can multiply the motor power with velocity of the vehicle, then we can reach the motor power requirement. So if you know the motor power requirement, then simply you can go and buy the motor which is available in the market. You can plug into your vehicle, then your vehicle is ready to run with yeah, electrical power, right? So that is the simplest, that's why we are calling it as a simplest concept, simplest control comparatively the IC engines. So to reach that level, you should calculate all the forces, right? So let us take one by one. So what is the rolling resistance force? The rolling resistance force nothing but it's the opposite force. So that force can be created with the due to the friction effect between the tire and the road. So see here, if any two object is meeting together, there will be a called friction. Since the vehicle tire will be the high speed, like that is called RPM, like a 2000 or 3000 RPM, then obviously we know that the friction friction may exist, right? Exist. So we have to calculate. So there is a formula called mu RR M into G. So the mu RR nothing but this is called rolling resistance constant. So based on the tire material and tire road, so we can choose this range, right? For example, if you classify your vehicle, so that is called what a passenger vehicle and goods carrier vehicle and off-road vehicle, on-road vehicles, right? These are the classifications of vehicles. That is called type. Depends the conditions. For example, if you take off-road vehicle, so there the rolling resistance constant will be high, right? Rolling resistance constant will be high. Whereas the smooth road, if you are driving your vehicle on the concrete road. So there is no any frictions. So smoothly the vehicle will get travel. Design of the particular vehicle, the air pressure will create, right? The air pressure will create. Suppose if the vehicle is in the standstill position, this pressure will not exist, will not be there. If the vehicle is in the one direction, then the pressure will be high. So now we have to overcome the pressure. So how we can overcome the pressure? How we can overcome the pressure? See here, see something. If you want to fly in the air, see your body structure should be, that is the frontal area should be as very thin. So in that case, we can avoid the pressure, air pressure in the infronter. That is called, that will affect your speed, right? So if suppose if you want to overcome this pressure, then we need a more motor power requirement. So simply we can avoid the simply we can reduce the pressure by changing its dynamics. So if you take a sedan type or sedan type vehicle, that vehicle speed will be very high comparatively other vehicles, because of its dynamics. That is called aerodynamic designs. People are you can hear the, I mean what can you may get a chance to see the advertisement aerodynamic drag designs. So like that the people will tell. So here if your vehicle is in this direction, so we can avoid this area. You can avoid this direction. Still we have to calculate this pressure. So for that one, so the off is the constant, rho is also constant, the air density. So this is going to be a constant, and A is nothing but the frontal area, right? So A is nothing but the frontal area, that is called length and multiplication of width and height, and drag coefficient. So this is also going to be a constant. So based on the design, that is the vehicle design, then you will get a this value. And then velocity of the vehicle, still what is its maximum velocity of the maximum speed of your vehicle? That is the velocity of the vehicle. So if you add all together, then you will get a aerodynamic drag force, right? Similarly, the drag coefficient. So here you can choose the drag coefficient based on the vehicle structure. And the hill climbing force. So here the next one is the hill climbing force. When you are because our road system is not a common, the road system is not a flat surface, right? Sometime it will be down, sometime it will be high. So when the vehicle is in down gradient, then the motor power requirement may be very less. Whereas if it is the up gradient, or if it is a vehicle in the hillside, then you need a more power to overcome the inclination path. So in that conditions, you have to calculate that too. The maximum, see here, this is called angle. So this angle, if the angle is high, you need a more, you need a more motor power requirement. So is m. If this is the, like, let us take, this is the 25 meter. If you are going to construct on bridge, so the bridge frontal length and then back length should be like this. So if it is a 25 meter, then the height of the bridge should be 5 meter. So if you have to count, you have to keep the percentage up to 20%. If it is a 10, then similarly you have to increase this step, right? So like that you have to calculate the total force required to cover this inclination path. And again one more power is there, that is called accelerations. There is a two acceleration, one is called linear and angular acceleration. So that I will cover, I will cover in the day 4th. So because that requires more calculations, acceleration force. So that part I will tell you with calculations. So now we can move how to calculate the motor power alone. So now let us assume this. Let us assume that we are going to keep the park the vehicle on the flat surface. So like that we can assume the conditions, right? So if you add all the total all the forces multiplied by the V, then you may get a total power. So each and everything will have a calculations. Similarly, the angular acceleration, just take this formula alone. I will tell you the in the day 4th class how we are achieving these calculations, right? Now let us take the typical, typical data, 1000 kilogram weight, and then the width is 1 meter, and then height is 1.5 meter, and rolling resistance, we assume, these are all the assumption value, right? Rolling resistance, air density, drag coefficient, and gravitational force. These are all the assumed values. These are all the assumed values. These parameters are going to decide your vehicle specifications, right? And another data is called vehicle velocity, that is the maximum speed of your vehicle. So the maximum speed of your vehicle is 140 kilometer per hour. So if you convert the speed into velocity, so that is called kilometer per hour. So just convert meter per second, right? So meter per second. So you have to convert the kilometer to meter and meter per second. Into second. So if you convert this one, then you will get 11.11 meter per second. And then frontal area. So if you multiply width and height, you will get a frontal area, right? So here we assumed that we are going to concentrate the vehicle, we are going to park our vehicle on the flat surface. So now the hill climbing and the acceleration force we will consider in the fourth session. So now we will take only the first two parameters, that is called what rolling resistance force and then aerodynamic force. So this is for simplicity, that is understanding purpose I took, and for actual purpose we have to take two more forces, that is that hill climbing force and then acceleration force. Okay. Now, so now if you apply this value, you will get a motor power. Total tractive force will be 230, and total power required to reach the to run your vehicle at 40 kilometer per hour is 2.5 2.5 kilowatt, right? So 2.5 kilowatt is the motor power requirement. So if you have this calculation, simply you can go and buy a motor higher than this value, not less than this value. You should have a higher value, right? So this is the actual motor power requirement to drive this vehicle at this specification. So now we can simply buy like a DC motor or BLDC motor or PMSM motor or induction motor or SRM motor, whatever motor you want, you can go and buy more than this value 2.5. The required value is 2.5 kilowatt. So you at least you should have a 20% higher value. Then only the motor will operate, because you cannot run the motor at 100% efficiency. Always there will be a cushion efficiency called 80 or 70% only you can operate, right? So for that one, so for that you have to apply a motor value, right? So if you will change the velocity, this graph and all I will tell you in the later. Actually today I think two uh, time is over, so we will tell you one by one. Try to engage with the entire class. So this is sample data. So if you take the sample data, you will get a detailed explanations. So I already modeled this one due to that non-availability of the time is very limited. So I took this is simple simple example. In the next class, I will tell you step by step explanations how we can include, how we can add this value each and every block, and we can run this one. So this is called vehicle body. So in the Matlab Simulink, see here, this is the Matlab. If you open the if you open the Matlab software, you will get a window like this. And here in this window, there is a block called the Simulink block. This is the Simulink block. If you click this Simulink, you will get a window like this. And here you have to create a new block. Here you have to create a new block, right? And once if the block is created, once if the block is created, then you will get a window like this, right? So here as I already told you, if you have any mathematical equations, you have a block to solve the equation particularly. So where you may get all the blocks. See here, this is the library blocks. This is called a library browser. So here you can identify all the blocks, right? Here you can identify all the blocks. Now we need a now we want to model one EV structure. That is, without motor, we are going to just model one EV structure, which means that vehicle body and tires, and then we are going to connect. Right. Whenever I access my Matlab, that buffering happening. So sorry for this. Sorry for this buffering. Yeah, time is over. Yeah, I know. I know. So actually, I will teach you. I will teach you how to develop model like this. How to develop a model like this, how you can do the result, how you can verify the results. So everything I will tell you. So my intention is to give you the complete insights about the concept, but due to the internet buffering, I'm going to wind up the session now. In the tomorrow session I will teach you how to start one by one. Okay, I am going to start. I will teach you how to how to connect and how to view the results one by one. I hope you understood, right? Yes. So, so once if you model this body, then you can run this vehicle and you can verify the results. You can verify the results at this level. Here, how we can verify the results under, there are multiple solutions are there. See here, this is the speed which is in the negative directions. The speed is in the negative directions. I will tell you why it is in negative direction. Similarly, how we can be modeled. See here, this is the vehicle body. So this vehicle body is connected with the two tires. So one is the frontal tire and another one is the rear wheel tire. Okay, so here this is the rear wheel tire and this is the hub. So you can connect the tire with the vehicle hub, vehicle body hub, right? So here the hub H denotes that hub, and similarly this is the rear wheel axis and then front wheel axis, right? And this is the measurement vehicle velocity, that is the body velocity we can measure with the help of the scope. And these two parameter, that is called wind input as well as that gradient input. So the gradient input, so here manually we are providing the input. So the gradient nothing but, as we know, as per our conditions, what we took like what we assumed, that we assumed the vehicle is in the without motor. Vehicle will have only the body and then tire. Okay, now we can test the vehicle, the two cases. We can test the vehicle in the two cases. One is that upward direction and another one is the downward direction. So this is the upward direction and this is the downward direction. So if you keep the vehicle at this position, what will happen? The vehicle move in the reverse direction. Similarly, if you keep the vehicle in the forward direction, then here vehicle will move in the forward direction, right? This is called reverse direction, called the forward direction, right? So that's why we are getting this one. So this is called the upward direction, and if you keep the value in the negative slope, then the vehicle will be in the forward direction. I'm here for next 30 days. See here the 30, plus speed. Earlier it was the negative speed, so now it is a plus speed. Like that we can model the vehicle. I will tell you one by one. So here I'm only for you for next 30 days. You don't worry, you will get a complete insights about the EV designs. So try to engage with the entire sessions, right? And I will. These are the theoretical parts. So if you are interested in the internship, you will get a certificate by email. For that one, you will get a internship program. So here you can join the VP group, WhatsApp group, and you will get directly. You can get a support from me. How to, I mean, what, how to do and how to develop your own vehicle and all. So that is the cost is only 590. The link is available in the description box, so you can get. And if you are interested, is 11th February 2023. 11th February 2023. Right? So you can join over there. If you have any doubt, you can ask me. I will try to give you the answers. And this is my WhatsApp number, so you can post your queries here also. I will give you. I am here to help you. Yes, so much buffering. I'm extremely sorry for this buffering. Yeah. I agree, Mr. Vigneshwaran. My side, I hear the network, heavy network issue. So tomorrow I will try to record the session. I will post here. I will record the session and post here. Sorry for this inconvenience. Sorry for the inconvenience. So hereafter I will record the session and I will post here. So you can attend the session. You can ask me the questions in the live chat box. I'm here to answer your all the questions. I'm here to answer your all the questions. You can post your questions. I will try to give you the answers. So this lecture will be removed. This lecture will be removed in next 3 days. So YouTube class will not be available no longer. I mean, will not be available more than 3 days. So if you need a internship certificate, you have to join in the internship. That link is available in the available the description box. You can get it. Thank you, Aditya. If you have a yeah 900 fees, you just apply the coupon code. You will get a discount. For the internship certificate, you have to pay 100. I mean, you have to pay 590 rupees. Otherwise, you will get a participation certificate. 590 is the final price, so you can check it. Thank you, participants. Yeah, Mr. Global Knowledge. My side, I'm a huge network problem. See here, my area, the people are what ditching the roads. That's why the problem is heavily available, heavily rise. So tomorrow, I think I will solve the issue. Yeah, yes, Karthik, I noted. So tomorrow I will record the class and I will upload it so that you will get without a disturbance. You won't get any disturbance. Thank you, participants. Matlab version, you can use any version, Dr. Rambuta Priya. You can use any version. You can use any latest 2023 also, not an issue at all. Thank you, participants. Thanks for a valuable time. If you have any questions, you can post here. I will try to give you the answers. Showing a payment link is 999. So just apply the coupon code, Mr. Raju. PPT will not be available in the open platform. You can download the PPT in our LMS portal. If you have joined in the if you have joined in the internship, so you can get what you can get all the classes like LMS. See here, after joining in the internship, you can directly go to the our LMS website. So here you can get a TV bundle. So see here you will get a complete classes. So you can download the MATLAB simulations. You can download all the presentations, everything. You can download the PPT, you can download the simulation files, everything you can get it in the internship. Whereas for the YouTube sessions, you can post your queries. You just follow the live sessions, and you can practice on the live only. Yes. So all the sessions are available. If you are interested, you can go and join the internship. You can download it. All the notes are available to download. Thank you, participants. Thanks for valuable time. If you have any questions, you can post me. Just to take my number. This is my WhatsApp number. So 98409744408. So if you have any queries about your research activity or your laboratory requirements, you can post your queries here. Thank you, participants. Thanks for your valuable time. Thank you once again.